The other type of isomerism is stereoisomer, where the atoms are connected in the same order but with different orientation. Sometimes we call it in a different spatial arrangement. There are two types of stereoisomer. The first one is geometrical isomer, where it may exist in the presence of double bond. The second one is enantiomer or optical isomer, where it exists in the presence of chiral carbon. Don't worry if you have no idea what chiral carbon is at this moment. We will come back to this soon. So let's start. Geometrical isomer. Due to different in nature, CC single bond and double bond performs differently when there is bond rotation. Here is an illustration. For CC single bond, the cap of the pen hold in position after rotation, which means the bond is free to rotate, or we can say the CC bond still holds after rotation. But for CC double bond, just like the pen with rectangular in shape, any rotation will lead to removing the cap from the pen, or we can say the bond is broken during rotation. Unlike single bond, CC double bond cannot rotate freely. That means when there exist different groups in both carbon atoms in the CC double bond, they cannot interchange between each other, results in two different compounds. Consider the following example. Both molecules are 1,2-dichloroethene. The one on the left-hand side contains two chlorine atoms on the same side. This is called cis isomer, where the right one have two chlorine atoms in opposite side called trans isomer. As we can see, these two molecules have different shape or net dipole moment. Their physical properties are different for cis isomer. Since the dipole moment from two C-Cl bond reinforce each other, there is net dipole moment, while for the trans isomer, the dipole moment cancels each other, make the trans isomer become a nonpolar molecule. This difference can be shown in their boiling points. Cis isomer has higher boiling point, which depends on the strength of intermolecular force. However, the shape of trans isomer is more symmetry, which leads to better packaging than cis isomer. This results in higher melting point of trans isomer. As the melting point depends on the shape of molecule, a more symmetry shape means the molecule can be packed better in solid state, which means more energy is needed to melt the solid